So I'm currently an associate professor at the Web and Internet Science group at School of Electronics and Computer Science in Southampton. And my research is very much into IR, and I call myself information access, and I sometimes also call my research AI, because it all depends on who I'm talking to and in which context. But actually, the core of my research is very much in information retrieval and developing user-centered information retrieval technologies for different problems. Okay, and also I'm very much interested in exploring the future directions of information retrieval since ChatGPT's arrival, and things are changing like fast and dramatically. So what is the future in this field, which I also want to explore, and especially to explore that from what does that mean to the users, to the customers? How do we engage them and then hold them and support them to use our technologies and to do meaningful things for them and for the society? Okay, so my research. My research, the right beginning when I was doing my PhD, I went into the field of information retrieval, but in the multimedia information retrieval, and focused on image search. And so I don't know how many of you have actually worked in the image search. A bit, okay. No, many, a bit, yes, a bit. Okay, so why image search and how do you search images? So normally when you search images, at least I do, is go in Google and type in the keywords, whatever I want to search, and then to find the images, relevant images for my needs. Is that how you also search the images, or you have different ways to search images? Pretty much the same. Okay, and then in Google, I don't know, you have noticed that they have this functionality where if you find the image you sort of like, and then if you you can actually see some more with the filtering function, you can see some relevance images like visually looking like that one you selected out of all the different roses, for example, in this example. So I don't know how exactly Google works, but this particular technology, we do have that, we work on that a lot in the labs. We call it visual similarity-based search. So you're searching based on the visual features of this image rather than the annotations. The reason is lots of images are not annotated. And in information retrieval, we know that we can only find things if they are indexed. Like anything are not annotated and indexed, you can't see them basically. And then how many of us actually annotate our photos, for example, uploaded photos? Do you bother to do that? And then there are technologies can do the automatic annotation for you, but again, that can develop a bias and errors. And also that could be, you may not be able to do the, or maybe you can only do a fraction of the image to annotate it. So that's why this technology become very important. For example, another problem is if you see an image very complex like this, I don't know, maybe the football fans here knows what that is. You can search it easily. But for me, I don't know much about football. It'd be difficult for me to, how would I search this? Should I say a football final or which football final? What query should I put in the search box to be able to find it? Any suggestions?
I know the context. I can give you the precise thing. I don't know if that's what you want.
Okay, no.
No. Then
Yes.
someone else.
Okay, you know this one. What about this one? Can you explain that? What would you say to the search engine if you are looking at architecture like this?
Postmodern.
I don't know. This this actually
futurist even.
if you know Chinese, if you know the Mandarin, you could describe this shape. But by the way, this shape is called a ren and means human in English. You can sort of, if I look at this, I could say this ren-shaped building. I may be able to find it. But if people don't know the language, it'd be difficult for them to express how this building is and what is it to find it out. So this situation like this, even they are annotated, you still can't find them because they are difficult to describe. So therefore, we had this keyword-based image search, and then the next technology came out called a content-based image search, which is try to solve the problem like that. So you no longer need the keywords, you just need to use the image features like the color, the shape, the texture. There are many of the image processing techniques nowadays available for you to use to understand the image and be able to find the images through those low-level feature matching without even knowing what the image is about. So if we have that function, then you will be able to upload the image and then be able to find what that image is about, basically. Is that the right answer, Luis?
Yes.
Yes. Okay, so for that one as well, so is a building. Actually, they did say must be a Chinese architecture did that, but yeah, they did use that character in Chinese to inspire them to make the building like that, like a bridge covered on top of the river. So that is why this technology become very helpful. And helpful technologies also comes with challenges. So because the accuracy for content-based image search is much lower than the text search. In Google, you may get 98% of accuracy, but for those image search, content-based image search, at least in my lab searching sessions in the technology when I did my last experiment, that was maximum 87 and some even down to less than 10. So it all depends on the images, how complex they are. And of course, what technologies and measures you use as well. So this is one of the prototype I developed in lab. And what we find is in the image search, there's a big gap. It's called a semantic gap, is how the computer understands the image is very different from how machine understands the image. So often when you search images like that, you will be recommended some images which is completely like you don't understand why the computer is giving you that answer. And then there's no logical to you, but to the computers, is very logical to them and is a very good answer to them. So how do we bridge the gap? There are a few ways and people exploring, but one way I used is to see whether we can actually design the interfaces and the search, the interaction to help users to understand what the data is like, so they don't get too disappointed, and give them the tools and features on the interface to help them to handhold them to interact with the system and help them to find a better result from this, whatever the limited information in the data sets. So that is one of the attempts which I did and which proven to be very helpful. But I also noticed people are very different. Their likes and dislikes, so we try to hold their hand, but some people want firm hand holding, some people want to be loose hand holding. So how do we know when do we give them lots of prompts and help, or sometimes we should just give them a little or not at all? So that inspired me and motivated me to look at the user's preferences and how do they search and what do they prefer with what situation. And by doing that, there's lots of people working on data-based modeling. So they look at search logs and then to try to explain the behavior through the data. And but I also, from the other side, top-down level, I also find it's very helpful to use some existing theories which can actually guide us to have a quick start on understanding humans' behavior. So there's ongoing research which I'm currently working on is to look at using different models to look at how we can use the model to help us to design the interfaces and interaction to help the user's preferences and search behaviors. So the first theory I applied to design the search interface is called the information foraging theory. Has any of you heard about that theory? You have? Oh, okay. Oh, yes, a few of you. Did you use it for your work or?
No, there was a thesis from Glasgow, I would say, touching on it, David Maxwell. I remember seeing that results.
Yes.
Apply it anyway.
Yeah. I see. Okay. So this is a theory originally came from biology. Optimal foraging theory is to initially in biology explains how animals look for food is very like how they decide when they eat this at this place and when they move to a different place and to look for food. So in 1999, Piroli and Card, they actually adopted the theory from biology into information science and to look at how people search. Their hypothesis is how people search for information is very similar to how animals look for food. So in that theory, there are three different models. So one is called the information scent, is what are the cues you give to people and to attract them to your resource, basically. And then the patch, there's a information patch model, which is explains how you can cluster the information on different topics or whichever way you want to cluster them, group them together. And then the information diet model is to model users' behaviors, information behaviors on some people. They are very they're very generous, like they're quite easy to please. If you give them the information, something relevant, they'd be quite happy, but others may be quite picky. They want to find exactly what they're looking for or that information they need. So this theory sort of explains this behavior. And so I adopted it into the search domain and to look at, can we explain users' image search behavior when they search those images by this theory? So based on the data we collected, and we actually try to make some analogies into explaining this user's search behavior with this based on the theory. So what we find is some people, they have very much fixed information goal. They sort of, before they start to look for information, they already know what they're looking for. Either maybe they had a very clear task, or they maybe had a problem, they know exactly what they needed to do to solve that. And then there are others, they have very much evolving information goal, which is very much like exploratory search. You may have a vague information goal or don't know what you're looking for at all. You're just exploring and searching, and then you're refining your goal. And then so it evolves. And then the information patch model can explain some of users' search strategy behaviors. Some people, they're very cautious. They like to change the query or click on use the functions very carefully. They don't want to dramatically change to somewhere they want to do, so then they lose whatever they have now. So they want to keep it steady. But others, they're very risky. They just try this and try that and change this query into a completely different one. And then, yeah. So we observe the different types of behaviors, how they interact with the information and the system. And then to link to the information diet model, we defined this evaluation threshold, and then to say, we commonly, when we do the system testing, we use relevance judgment files. But when you do the user study, you ask them, maybe we say this system is accuracy or is 90%, but the user may say it's 50. But we noticed that it all depend on their evaluation threshold. When they are very easy to please, when they have a weak evaluation threshold, they tend to be more easy to be satisfied. But when they have very precise evaluation threshold, it depends. Sometimes if you give them good guidance, they may be very pleased, easy to get a more better satisfaction as well from those hand-holding to help them to find the process information they are looking for. And after that work, we further done more work, because information foraging theory, although you can adapt it into understanding user behavior, but we curious about whether what's those, why user behaves like that, what's happening in their mind. So we looked into some like psychology theory, and then to see whether we can find the synergy to find the alignment if those human behavior and why some people are more decisive and some not could be explained, assisted to explain by them. So we looked into some psychology theories, and we extended this model into finding some further confirmation from this growing and fixed mindset in the psychology theory, which aligns very well with this. And we actually developed some, through the observation, developed some suggestions on what feature you may put into your search system to help you, particular types of users to complete their task and use your system. And then after that, apart from that, another theory I explored with one of my PhD students is cross-cultural theory, where we, because she's have this expertise of looking at the localization of this, how the system is designed locally for different branches. For example, McDonald's, they have different branches in all over the world. If you look at the design of their interfaces in different countries, they look completely different. So they are all designed, localized by the culture preferences. So we used these Hofstede dimensions from the social science cross-cultural theory. I don't know whether you heard about this theory in the past. Is talking about how the different cultural background or cultural beliefs and cultural behaviors actually impact on how people comprehend and interact with the information and with the system and the information. So this is the paper we worked on to try to map these different dimensions and into the search system design. And then they, in addition to that, I also worked on with a student who is very much believe in positive emotions. So there's a theory talks about if people have a positive emotion, they're happy, they will be much tolerant into accepting whatever technology you are presenting to them. And through those positive emotion and could be implemented into your system through some positive emotion stimuli. And in this research, we worked on how do we design the search systems by introducing here, we had some bubbles, and then to introducing their life, basically the context of their search, and maybe photos or information images, or they are able to chat with others, the collaborative search. How can all those different features can help them to develop a positive emotion during search? Therefore, they will have a better interaction and better satisfaction with their search experience. And another thing, apart from the interface perspective, other things we also worked on, with Amit was sitting here as well, and on how do we, from system side, okay, after we understand people's, not all, but to some level, we already understand what they like, what they dislike. Then how do we implement that into the system? And then, for example, with the information foraging theory, we know if we give them a very good information scent to tell them where the informations are, and give them the guidance to reach to their information patch to find those information, then that's a step forward and hand-holding to help them. So we experimented in the system side. How do we design that? How do we make the system to work like that? So in this few works Amit worked on is to use this multimodality search functions and use the query expansion to help help the users and provide the users with the information to help them to find the information they need. Not only the text, also the images at the same time, even matching the text with the images, the patches of the images. So to help the users, to get the users to find the, to refine their query, to find the, explain what they were looking for. Okay, so those are those works, and we also worked on from the system side as well. What we learned is users, they are better trainers for the system. So especially when you use those machine learning algorithms in the search model, you want to learn. But if you can't pre-train the model, then what do you learn from? So you want to learn from the users, like the user to train the model rather than you pre-train the model. Therefore, we can make the model more personalized for the users' search behaviors and needs. So we used this, designed this system which can allow the users to be able to look at, give some examples of the images and to help the system to train the model, basically, to start with. And we did some study in this paper, not only through the systematic testing, relevance judgment files, we also did a user study and through eye trackers and emotion detections, and then to find out this training process is not only helping the system to be more accurate and for the user's needs, also help the users to engage with the whole search process. And then the last thing which I'm also working on with another student, which is slightly different from the search tasks, but on the classification and prediction tasks, is to use the federated learning to work on the health domain to prevent, to improve the privacy and security. And also the image, because we're working on the health images, so to see how we can train those models to work on different types of health images through the this federated learning technology. Okay, so that is all the references I have from those papers, if you want to have a look. And thank you very much.